Monte Carlo methods have become an essential tool in machine learning, helping to improve model estimation, uncertainty quantification, and optimization. These techniques enable models to make better predictions by approximating complex probability distributions and exploring large search spaces efficiently. Why use Monte Carlo in machine learning? Machine learning models often involve randomness, whether in data sampling, training algorithms, or probabilistic modeling. Monte Carlo methods help by estimating probabilities when exact computation is infeasible, approximating high-dimensional integrals in Bayesian inference, improving decision-making under uncertainty. Key applications of Monte Carlo in machine learning. Monte Carlo methods are widely applied in different areas of machine learning. Bayesian inference. Monte Carlo simulations allow Bayesian models to approximate posterior distributions. Techniques like Markov chain Monte Carlo (MCMC) help sample from complex distributions. Variational inference uses Monte Carlo approximations to estimate model parameters efficiently. Neural networks and deep learning. Monte Carlo dropout is a popular technique for estimating uncertainty in neural network predictions. Improving generalization by applying dropout at both training and inference. Enhancing model robustness in applications like medical imaging and autonomous driving. Reinforcement learning. Monte Carlo methods are critical in reinforcement learning (RL), where agents learn through trial and error. These techniques help in policy evaluation, estimating the expected return of actions. Monte Carlo tree search (MCTS), a strategy used in games like AlphaGo to explore future moves. Sampling-based optimization, finding better policies in complex environments. Hyperparameter optimization. Machine learning models require careful tuning of hyperparameters. Monte Carlo search strategies help by randomly sampling different parameter values, estimating the best configuration without an exhaustive grid search, reducing computational costs in large-scale models, uncertainty quantification. In real-world AI applications, understanding uncertainty is crucial. Monte Carlo techniques help quantify confidence in model predictions, improve decision-making in high-risk applications like healthcare and finance, detect out-of-distribution samples for anomaly detection. Challenges of Monte Carlo methods in machine learning. Despite their advantages, Monte Carlo techniques have some challenges. Computationally expensive for large-scale models. Require careful tuning of sampling strategies. Can be slow to converge in high-dimensional problems. Conclusion: Monte Carlo methods have transformed machine learning, enabling better uncertainty estimation, optimization, and decision-making. Whether in Bayesian inference, neural networks, or reinforcement learning, these techniques help models become more accurate, robust, and efficient.